Hi, team. Thank you for showing up for your learning. Sorry, I can't be there in person, but I am here standing by, ready to answer your questions by email. So certainly you can always contact me that way, and I'm pretty sure I'm going to be there tomorrow. So first thing that I'd like you to do is you can go ahead and pause this video, go inside the content tab of our D2L, go to Unit 5, and then go ahead and read this comic. Either that, or you can listen to me read the comic if you like the sound of my voice for some strange reason. And now now that you've paused the video and gone and read the comic, you have a good idea of why we use trigonometry in these various situations. A lot of times we'd like to measure something, but we can't measure it directly, but we can create triangles that we can measure directly and then solve those. One thing that I find challenging is working with problems that aren't in context. So I want to show you some of these. If we have like a triangle, and here's a tip about how we talk about and draw triangles, and this will help you with some of the textbook problems. When we draw a triangle and we label the corners first, A, B, and C, or F, P, Q, and R are popular, or just any three letters in a row. Any three letters, doesn't matter. A, B, and C. And then we label the sides with little letters, lowercase letters. Little c, little a, and little b. And little b is always across from big B. Little c is always across from big C. And little a is always across from big A. So you'll want to remember that that's how we draw triangles. That'll help you in future topics, particularly sine law and cosine law. Okay, but now in this case, we have a right triangle. So we want to draw a diagram. This is our first step with all of these problems. Use the whiteboards, use lots of paper, make big diagrams. Okay, so we're going to make a right triangle here. Whoop, boop, boop. Okay, good. And then it's a right triangle, so label your right angle. And then we have a 55-degree angle in it. So I'm going to say that's about 55 degrees. Okay. Oh, and one of the legs is 13 long. It's 13 units long. And the legs, not the hypotenuse. So let's say this one. Sure. This one is 13 long. Okay. Let's solve the triangle. What that means is solve the other angles and solve the sides. So to solve for this angle up here, let's call it A. All right. And so we would have angle A plus 55 degrees plus 90 degrees is 180 degrees. All three angles are supplementary because they're inside a triangle. And then we can subtract 90 from both sides. I mean, you could do both, but we're just going to go A plus 55 degrees. And then we subtract 90 from both sides of the equation. So that's going to be equal to 90 degrees because 90 minus 90 over there is 0. And 180 minus 90 over there is 90. So what I'm showing you here is that these two angles, this one and this one in a right angle, are always supplementary. In a right angle triangle, those two angles are always complementary. They always add up to 90 degrees. So let's find, what do I add to 55 to make a 90-degree angle? So here, what plus 55 equals 90? Well, it happens to be, is that 35? Yeah, 35 degrees. So we can find that by subtract 55 from both sides. And we get angle A is equal to 90 minus 55 is equal to 35 degrees. Okay, so there's one piece of information. You could put it on your diagram. 35 degrees is this angle A up here. And now let's find these other sides. Let's call this little b and little c, because 13 would be little a. Okay, and then we're going to be able to use trigonometry to solve for those sides. So what we're going to do is we notice that this side down here, which is adjacent to the angle that we drew, is known. So we can use cosine of 55 degrees, which would be a ratio of the adjacent side and the hypotenuse. Because we remember SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And that's the ratio that we're going to use here, 13 divided by c. So that will allow us to solve for c. So to solve for this one, let's go ahead, multiply both sides of this by c, and then we will have a new line, which will look like c multiplied by cosine 55 degrees is equal to 13. Cool, because these c's will cancel. And then we actually want to solve for c, so let's go ahead and divide both sides of the equation by cosine 45. Sorry, cosine 55. Okay. And if I do that, no need to write a new line here. These cancel, so I have c is equal to 13 over cosine 55. That's what we're going to go ahead and punch in our calculator. So 13 divided by 55, but I take the cosine of it, gives me 22.6. So let's keep a one decimal place. That'll be 22.7. It will round up. So C is equal to 22.7. Okay, so we can put that on our diagram here. 22.7. And that should look reasonable because it's longer than 13 and substantially longer, almost twice as long. So that's pretty good. And then we can solve for b. Now we have two options of how we can solve for b at this point. Because we have two known sides, we could use Pythagorean theorem, or we could use a trigonometric ratio. Okay, so the trigonometric ratio that would relate this adjacent side to this opposite side. Remember, the opposite side, I have to cross the triangle to get over there. The adjacent side is right next to that angle. So yeah, it's the trigonometric ratio that relates opposite to adjacent is tangent. Tangent is opposite over adjacent. So, ka, toa. So we're going to use toa here. We're going to use tan. All right. So let's write that out. We'll work on forest green. Tan of 55 degrees. So I'm still working with this angle. Still this is my angle of interest. Is equal to the opposite, which is b over 13. And now I can, over here, just multiply both sides by 13, and I already have it. That will be the value of b. So in that case, this successfully isolates for b here because these cancel. So then we have the next line, which is going to be 13 times tan 55 degrees equals b, and then we punch that and solve it. 13 times tangent, oops, sorry, clear, no, my calculator. 13 times 55, but I take the tangent of it. You'll have to learn what order you put these things in your calculator. Oh, 13 times 55, but, 555. What's going on with me today? There, 55, but I take the tangent of it is 18.6. Okay, so B equals 18.6. Now the triangle is solved. We know everything about this. And so we've achieved our goal of knowing all the sides. And then when I look at it, 13, 18 and a half, 22 and a little more than a half, that all looks reasonable for a right angle triangle. And I can even check this with a Pythagorean theorem if I wanted to. Does 13 squared plus 18.6 squared equal about 22.7 squared? Probably does. So actually, I'm sure it does because I didn't make any mistakes. All right, so that's one type of question that you're going to work on today. Another type of question asks you to read and then make a picture out of what you've read. So here we have a guy wire, which is a tensioned cable designed to add stability to tall structures. So we're learning something new about what a guy wire is. One end of the guy wire is attached to the structure and the other end is anchored to the ground. So if we have a 60-meter tower, I start drawing pictures. Okay, start drawing your pictures and labeling it. So I'm going to draw something that looks a little bit like the Eiffel Tower. Maybe you think it looks slightly less romantic, and I would probably agree. Okay, so there's our tower, and it's how tall? 60 meters. Towers make 90-degree angles with the ground. Okay, so there is our tower. And then there's a guy wire that is attached to the top of the tower to keep it stable. It's straight line despite that little bloop that my hand did. And it attaches down there. Okay. We know the height of the tower, 60 meters, and we know that the guy wire makes an angle of 75 degrees with the ground. Here is the ground. Here is the wire. Between the ground and the wire is where you put that angle. And that's 75 degrees. We don't need to go ahead and solve this triangle. We just want to know how long the wire is. Let's call it length W. Okay. So now, once you've drawn your diagram, feel free to draw like a really simplified triangle of that as well. So there I would, I'm just going to zoom in so I can put these values in. That would be 75 degrees. This would be 60 meters, and we want to find W. And then I can see it very clearly. That's in the right angle. Okay. So here, I already know the side opposite my angle. I would like to know the length of the hypotenuse. I cannot use Pythagorean theorem because I don't know this, but who cares? We can use trig. So the trigonometric ratio that relates, I have to choose the proper trigonometric ratio at this point. And because I know the opposite and I want to know the hypotenuse, I will choose sine, which is opposite over hypotenuse. That's the ratio I want. So I'm going to start with this equation. Sine of 75 degrees is equal to, and you can even write it out, opposite over hypotenuse. And then go ahead and substitute in. Sine of 75 degrees is, I don't know the hypotenuse, but that's what I want to know. It's W. I do know the opposite, and it's 60. Okay. And then you go ahead and multiply both sides by W. That's so weird. I lose my drawing tools when I zoom sometimes. Okay, so we go ahead and multiply both sides by W so that W gets off the bottom. So we have W times sine 75 degrees equals 60. And then we're going to go ahead and divide by sine of 75 degrees on both sides. That's going to isolate W. Okay, so cancels, and then we have W is equal to 60 over sine 75 degrees. That's the exact value of W, but we were asked to find it to the nearest tenth of a meter. So let's go ahead to our calculator. We're going to punch 60 divided by 75, but I take the sine of it, equals 62.1. So that would be the length of this guy wire. We need the guy wire to be 62.1 meters. After you finish this question like this, write a sentence. Therefore, the guy wire must be 62.1 meters long. And that's how you tackle the questions for today. So any questions, I am available to you by email, so feel free to hit me up that way. Otherwise, I look forward to seeing you on Friday and discussing these types of problems, taking a look at the work that you've completed over the last couple days, and getting started on the next idea together. If you haven't looked at that comic yet, go ahead and read it or listen to me read it. I was hoping to be able to do a dramatic reading of it together today with one of our perhaps a dramatic student from the class, someone. But any case, maybe I'll make a new comic for tomorrow's topic. All right. Bye for now, everyone.